Hello everyone. Sawadee Namaskar. Welcome you all to Techno-based Plastics Tech Talk. Today's episode of the Plastics Tech Talk is focusing on the plastics recycling, a journey from linear to circular economy. Our invited guest speaker today is Mr. Mihir Banerji, a well-experienced, well-known plastics industry consultant. He's going to give us the journey of this plastic recycling from linear to circular economy. Before I let him give a talk, let me quickly introduce about his background, his profile, and his experience. Mihir Banerji is a polymer technologist in profession and a postgraduate diploma holder in marketing and sales management. He is also a fellow of Indian Plastics Institute. He was the past president of Indian Plastic Institute, a managing committee member of the Plastic India Foundation 2023, and also chairman Quality Standardization Committee member of Indian Institute of Packaging, a committee member of the Bureau of Indian Standards, BIS PCD 12, representing IPI, and PCD 27, representing Plastic India Foundation, Plast India Foundation, also representing the country as a committee member of ISO TC 61. He has traveled widely to pursue plastic-related activities. Since 2010, he is working as an industry advisor with the home appliances, automotives, packaging, and recycling industries. He is also Secretary General of the Plastics Packaging Research and Development Center, established jointly by 8 large flexible packaging manufacturers in India. He worked as a plastics technical expert in one of the programs jointly sponsored by UNIDO, a department of the Chemicals and Petrochemicals, Ministry of Chemicals and Fertilizers, Government of India, and plastics industry to import advanced skills in small and medium scale plastic industries. He worked as a plastic technical advisor for a technical study on supporting downstream polymers manufacturing industry sponsored by Ministry of Industry, Government of Kuwait. He is working in polymer industry over 45 years, a very long journey. Started his service career with ICI India, followed by Indian Petrochemical Corporation, shortly IPCL, and Reliance Industries, RIL. During his services, he gained experience in plastics manufacturing and processing, formulation, quality control, application development, technical services, sales and market research, and business development of PE, EVA, ultramagrate, HDPE, PP, and PVC. Mr. Mihir Banerji has undergone specialized training for LDPE, LLDPE, HDPE, PP application developments, processing at technical centers of ATO Chemie, Total Petrochemicals in France, Respol, Spain, BP Chemicals, and Basel, and with all international organizations. He has also received orientation training on LLDP extrusion machine design at a reputed German machine manufacturing premises. You can see I wanted to read this his complete profile so that you understand his long experience. It's a great opportunity for all of us to learn from Mr. Mihir Banerji, and he's really focusing on the recycling aspect. When I talked to him, I found that so passionate, so dedicated, and it's a great opportunity for all of us to learn from Mr. Mihir to talk about the journey of plastic recycling from linear to circular economy. Mr. Mihirji, welcome to the Techno-based Plastic Tech Talk. Over to you.
Thank you, Mr. Rao, and good evening to all of you, whoever participating. I will take you the journey of sustainability mainly and circular economy, how it works out and what are the standards of ISO and how people are working on it. Now, my main, that is Mr. Rao, first slide, you show me agenda. Next slide. Next slide, you'll go. Yeah. Now there, I will little bit brief about the consumption and why we talk about sustainability and what is the per capita consumption, what is the global production, and how the waste generation in different regions all over the world takes place, and how to make waste to wealth and circular economy, what is there. then recycling technology, different type of downcycling and upcycling, biopolymer versus biodegradable polymers, and finally I am going to European Union's whatever the regulation or legislations are there, and compared to Indian plastic industry, what is the regulations. Next slide. Yeah, next slide. There is the plastic consumption versus waste, the first thing. Mr. Rao, next slide. Yeah. Now, global production versus entire global production of plastics is 400 million metric ton. And largest production and consumption is P, all sorts of P, whether it is low density polyethylene or linear low or high density, or it's copolymers like EVA, EAA, etc. That is 140 million metric ton. And polypropylene is 89 million metric ton, which includes also polypropylene copolymers. And new capacity which is coming up further in polyethylene clays, 32 million metric ton new capacity is coming, and polypropylene clays, 27 million metric ton new capacities are coming. This is the worrisome for the people who are, maybe some of them are in the plastic industry, and most of them not in plastic industry, but they see that if the growth is so much, where the waste will go. Few days back, only a world meeting took place, international global meeting in Busan, Korea. Before that, last year it was in Nigeria, Nairobi. Their plastic cap, some of you must have heard about that plastic cap. What people are talking about now, the whatever production you are doing, there should be a capping. Further, no extra production, no new production should come. And in that case, if the consumption is increasing, then go for circular economy. Of course, India objected for that pact because Indian theory is there. Our consumption in India is quite low compared to Western countries or in some of the Asian countries. And if we capping that and our growth is coming up, then we will be net importer. In that case, we don't agree with this. Next slide. Mr. Rao, next slide. Now, if Asia Pacific scenario, if we see, Asia Pacific region is the growth center now, and it will continue for another several years, the growth center. Like PE production is 82 million metric ton. If you see the PE production in global is 140, and out of the 140, 82 million metric ton is Asia, and China alone produced 40 million metric ton, whereas PP production is 44 million metric ton, and where China alone consumed 29 million metric ton of polypropylene in Asia. That means rest with other Asian countries like India, Indonesia, all other, Japan, everything put together. So China is the biggest consumer and going to be a global hub for production. So much new capacity that China coming up, because so long China, almost 50% requirement, China depends on import. And a time China looking at, and very quickly they will reach to that level that where maybe very few they have to import. I will only talk about PE and PP because it is absolutely difficult in 1 hour to talk about entire polymer. So, which is the maximum largest production PE and PP and largest consumption? I will talk about sustainability on that. Next slide, Mr. Rao. Next slide. Yeah. Now, region-wise per capita consumption versus waste generation. Maximum per capita consumption, if you see left-hand side, North America is the highest, 185 kg. And as their consumption is high, Their waste generation, which right hand side, if you see, 53 kilogram. To be frank enough, I just wonder that US is so advanced, but their waste management is very poor. Almost everything go on dumping site, landfill. Next is Japan, 120 kg they consume and 37 kg is their waste generation. And this is the way, if you see the India consumption is 22 kg and waste generation 6 kg. Why this is, you will wonder why it is so low. Because we are very, very good in reusing. A good carry bag, even if we get, we don't throw it. Keep it as long as this carry bag can be used for different other purpose. Same way, say a PET bottle, mineral water bottle, it is used for keeping water in the refrigerator. An HDPE bottle, maybe for edible oil or whatever you have done. Once it is consumed, then this bottle reuse goes on. Long back, I remember I was doing a survey from Reliance side, or now IPCL side, HDP consumption in northern India in bottle blow molding. I saw in UP lot of small edible oil and vegetable oil producers are there, and they changed their design of the bottle. So one fellow told me, see, generally vegetable oil, which is called dalda or vanaspati, always wider mouth because it is become solid. And you have to melt it, so you have to take it with a spoon or something and put it on the cooking utensil. And second, after the your product is empty, the bottle is washed in smaller town and villages, and they use it for storing food grains. And similarly, edible oil bottle, always the mouth is narrow because in the villages there is an acute shortage of water in summer. So they fill the bottles in water and they keep the water in their house. And narrow mouth, it is easy to pour. That is the way. So we are very good in reusing. That is the reason waste generation 6 kg only. Next slide, Mr. Rao. Now, if so much global waste generation taking place, what next solution? First solution, always we think landfill, and landfill always is everywhere. Even who are from northern India, you know that every time there is a article in a newspaper or somewhere that so and so landfill, it is burning or all thing due to methane gas. Second, whether we should go for landfill or for burning, or whether we should go for degrading the polymer, or fourth option, recovery. And I personally feel, and a lot of people feel, the best is the recovery. And recovery means going to circular economy. Mr. Rao, next slide. Now here, I'm now coming to the circular economy and concept, turning waste to a gold or value addition. How to do? Next slide. Here you see economic value viability versus environmental impact. How to do? This box, top right hand side, you will see where positive value addition. How you can do? Mechanical recycling, where recover the material. And next is chemical recycling, where again go back to a polymer. Some value addition we have seen, mainly PE waste. If it is mixed with coal tar, it can be very well used for road laying applications, and which we have done here. So that also giving value addition. Of course, the road laying, rubber also used, there is a BIS standard for that. You can use a rubber, you can use plastic, you can use EVA, everything. But due to, I think, to be frank enough, vested interest, this has not been taken up. Because once the road is laid with this plastic, bitumen plastic, it will go on for say 5 to 6 years without any problem. That is the reason, maybe vested interest, but all the higher altitude roads, which is border road organization, they does, where the heavy snowfall is there, there it is mixed with plastics or SBS called styrene, butadiene, styrene, and almost 25,000 metric ton of styrene, butadiene, styrene every year imported in India for this road lay. Next, you will see also we have done some trial in cement industry for heating purpose, plastic, waste plastic. So there is some, of course we are burning, but there is some value addition is there. If we go to left hand side, that is the negative where it is. Some positive value burning because cement industry is going. But degradable means I am killing the product. Of course, one way I am reducing the waste, but I am killing the product. And last square, which is the left hand side bottom last square, landfill. That is the most dangerous thing. Now, which material, where it should go, that for that reason, a thorough life cycle study for all finished product should be done. And then only it can support you the sustainability that which one should go for where, whether it will go for degradation, whether it should go for cement industry or say road line or say mechanical recycling, it will go for that. Next slide. Like 3 pillars of sustainability which we talk about. First is reduce use. If I can reduce the use, unnecessary use where it is, like you are going to a grocery shop and buying a pack of biscuit, he may give a thin carry bag, but I should not take the carry bag because biscuit is already in a pouch wrapped properly. Why I should have a bag or a bread I am buying and then giving a carry bag? This is the way we can reduce the use. Then come the reuse, which I explained that we Indians are very good in reusing. And finally, when reuse after reusing, go for recycling. But when I'm going for recycling, I must think three. One, of course, economic value addition. When I'm doing recycling, I should have economic value addition. Now, when I'm looking for economic value addition, the process, what I am going to adapt, whether society will accept, because from industrial area, if polluted water is going or say air is polluted, society may not accept. And finally, I must see the environment, whether it is going to be effect to the environment again, carbon footprint, which is called. This has to be seen. Next slide. Yeah. Coming to the circular economy mantra. At present, the global economy is linear, like something you produce, use it, and dispose it. Finished. I don't bother that after disposal what is going to happen. This is called the linear economy. But if there is a capping is there coming in near future, then we have to think for circular economy, because when I am going for circular economy, where circular flow of resources by recovering means the recycling or whatever it is and adding their value while contributing to sustainable development, and this give me saving of the resource. ISO has given hordes of ISO standards. Some are in draft standards, some are already adopted. Like any organization, if he is declaring that my organization is sustainable, then he has to follow these standards. I'm not going very details about the standard, just I have given the standards. Mr. Rao, next slide. Yeah. Now an organization is talking about sustainability. How to measure the sustainability and circularity? First, the monitoring the goal and action. That means reduce the use, reuse, and recycle. Here, when I will come at the last about Indian regulation, reuse, there I will discuss. Second, coming measure resources flow. Inflow and outflow release losses. If I am going for recycling, what is my inflow and what is my outflow in that, and what loss I am doing? Third, the impact assessment, environment, social, and economic impact, which already I talked earlier. Sorry. And finally, core circularity indicators. Resource inflow and outflow, energy, water, economy, that also coming in resource. If my technology takes consume too much water, then I have my groundwater I am depleting. So what will happen to that water? That I also have to see. Next slide, Mr. Rao. Now I'm going to very briefly, I'm talking about recycling technologies. Any question after this my talk is over, always you can put it. Next slide. Now ISO as well as Bureau of Indian Standard has given a horde of standards. Like first is coming mechanical recycling. What they are defining as mechanical recycling: processing of plastic waste into secondary material without significantly changing the chemical structure of the material. Now this standard is in 4 parts. Next coming chemical recycling or feedstock recycling. Conversion of waste plastic into monomer or chemical compound. That is the chemical recycling they call. And third is physical recycling. Now chemical recycling and mechanical recycling already draft standard in ISO had been made. It is under approval, it will take some time. Whether physical recycling, still today ISO is not able to get proper experts who can work on physical recycling. Because physical recycling means say a compound, you have say filler compound where calcium carbonate or talc filled, which is of course used in automobile applications or say home appliance application or say fiber, glass fiber is filled. How to separate it out and take out the polymer for circular economy means again reuse. That is called the technology where physical recycling coming to. Keeping the polymer same structure, everything, only taking out the pigment or additive or say fillers, everything, making separate. Now here the come, when I have an waste, it is very difficult and very closely we have to see that which technology I should operate, take back. Like mechanical recycling I will go or chemical recycling or physical recycling. To be frank enough, chemical recycling yet hardly there is any proven technology, commercial technology. All are pilot plant or R&D system. Everybody talks about chemical recycling, but commercially hardly any material is available. Next slide, Mr. Rao. Coming to the mechanical recycling, there are two types of mechanical recycling. One is downcycling and one is upcycling. Now, recycling, if we talk, leader is China. I have widely traveled in China to see the recycling thing. Downcycling, when we are going, that means the polymer which I am recycling, that cannot come for the same application which I have done earlier. And upcycling means where I should have a material which is near prime back, so that back to the system. This is the difference for downcycling and upcycling. Downcycling is very much available, the technologies. China is the leader, but now they are coming up with upcycling. India also leader in mechanical recycling, but mostly downcycling. Then, of course, Indonesia, Thailand, Philippines, Vietnam, these people are there. Mainly Asian countries are leader in mechanical recycling since ages. Of course, now in European Union with their regulations, there are some recycling industries coming up. So there are two types of recycling. Either regulatory driven recycling, which is now in Western Europe or European Union having, and one is economy driven, which is in Asia. These are the two different things. One is regulatory driven, one is economy driven. Upcycling place where post consumer waste, when I'm recycling, I'm my aim is to make it value added product, and sincerely to be there, this value added product which is going for circular economy, and which is now it has come with European Union as well as in India, all the regulations. PET first has come up, and which is called bottle to bottle, means bottle is recycled and come back again to bottle manufacturing. And of course, PE and PP recycling, upcycling is taking place, but it is a challenge for PE or PP because major quantity of PE and PP is used for flexible packaging application like films, etc. And that is a challenge, and the technology is a challenge to get the real upcycled material. Lot of technology changes has to be done from rigid like bottle to flexible film. And this ISO draft standard for mechanical recycling is 5677. Next, Mr. Rao, next slide. Perspective, that is PET recycling perspective. Like there are some of the technologies which for upcycling, to be frank enough, I'm not talking about downcycling. So long PET, entire PET bottles was recycled because there is a acute shortage of PET bottle to available in India, and it is all going to textile application. And the material which is come out from the recycling for textile application, the price is lower than virgin material. But when we are talking about upcycling, means bottle to bottle, it is a different technology. Like one is pure loop technology, where actually washing is same, whatever you are doing washing line. But next step when we are going for making the granules, what type of vacuum system should be there, which will all volatiles to be taken and decontamination can be removed. Now PET case, when we are doing recycling, generally who are in PET business, blow molding, bottle making, they are aware that IV of bottle grade viscosity, intrinsic viscosity, is somewhere 0.68 to 0.7273. But when we are going for washing, that time chemical wash at a temperature of elevated temperature around say 90 degree, polymer slightly loses IV, slight degradation takes place and lose the IV. And the same thing very well it can be used for textile, but not in bottle. So for that reason, next phase after making the granules from the extruder, it goes for solid state polymerization, SSP process, where the further decontamination removed, contamination removed, and the IV increased. Now Visco take another technology where also the SSP is used, but latest technology which has come up, LSP, liquid state, where liquid state itself decontamination happens, volatile is removed, and straight it can go to the hopper for making the bottles. This technology, which I have been told that Coca-Cola is using in Japan, LSP technology. But another catch in this technology is there. Except bottle, other thing is difficult to make. Now coming to Indian condition, you may surprise 14,000 CR has been invested for importing the machine from abroad for specifically for bottle to bottle applications. And already 4 or 5 plants are operating. Another around 10 plants are in pipeline. I am really lucky that BIS formed a working group, Bureau of Indian Standard, for laying down the PET, recycled PET for food packaging applications. And I was one of the working group members. So a lot of things I learned. And final draft we have submitted last month. And hopefully by March, it will come out in print form. There we have covered all this technology and we kept something open because by the time it may publish, another new technology may come for this purpose, upcycling. And another surprising thing, a PET film generally goes for multi-layer application for pouch. So recycling is difficult. So PET bottle will be used for recycling and going for film applications as well as for sheet applications other than bottle. But in the case of film and in the case of some of the cases of sheet, you do not require SSP or LSP because generally film grade IV is 0.65 and a bottle grade when you're using an IV going down 0.65, it is okay. So one step you can remove. Here another greatest challenge is traceability. Traceability means how many times this bottle can be recycled and going back to mainstream for blending with virgin polymer, whether it is 2 times, 3 times, 4 times, or 5 times. Nobody knows. So my organization, that is Plastic Packaging Research and Development Center, we have already invested around 2 million euro to get tailor-made machines or optical system where when the conveyor the bottle scrap are coming from the bale, there will be a watermark and the camera will catch that how many watermarks are there and it will go to the recorder that the 3 times recycled or 2 times or 4 times. And this thing already we have done the testing of this. So this will be in AI system in the blockchain will be there. So a recycler immediately can open his site and see that so many bottles are 5 times recycled, so many bottles are 4 times they mix. What is happening? Final product, that bottle blowing, because a blow molder, he want uninterrupted production. If any wastage is there, bottle price is going up. And this information he will pass on to his customer, that is a blow molder. And in AI system, he is checking also that what is going to happen if this mix is already 4 times or major quantity is 4 times recycled already. So what is going to happen? Accordingly, he will adjust his machine. And finally, the same AI system app will be with a brand owner, like who is making a mineral water or say beverages. He will know that this supply, because every data they are putting in that AI system, a blow molder or recycler. So he can get the data and he knows that what is what in this whole bottle. So this is called the traceability during recycling. This is maybe take 2 years because already work has started, and by March some trials will take, because nobody thought in the world something. Nobody thought. This is the first time we are doing, and maybe we can be first who will come up with this type of idea or technology. Mr. Rao, next. Now, chemical recycling, if talk about what are the technologies ISO recommend. That is called, first is synthetic gasification, to convert mixed plastic waste into hydrogen, carbon dioxide, carbon monoxide, and steam. But here, hydrogen, I can use it for hydrogenation cracker, where other carbon dioxide, carbon monoxide I have to release and steam. So how much circular economy is coming, I do not know. Pyrolysis oil extraction. Yes, a lot of people are doing pyrolysis oil. Even it is very, very common in the rubber industry. Mr. Rao may say their old tire and all these things, pyrolysis oil. We are trying that whether this pyrolysis oil can be used in a polypropylene or polyethylene production reactor or say cracker, and from there with naphtha or gas mixed, and then it comes polymer. Then if that is coming, that is real circular economy. We are working on this. I do not know whether it will be successful or not. That all waste will go for pyrolysis oil and then cracker to polymer. Now next technology, which is they say depolymerizer process, to break down into monomer. And that monomer again can be used for making polymers. And catalyst cracking again to get the monomer. And solvolysis means breakdown of plastic and separation, like a multi-layer film. For PET or BOPP is there, P is there. That P layer will get separated and BOPP or PET films layer will get separated, and then separately that can be recycled. This is a technology and which we are working on this technology. And to be frank enough, the organization which I am heading, that is a purely voluntary organization, is a trust. So we give free of cost technology. What we spend money, the trust spend money, and when the technology is there, we give the technology. Like one technology we have got it from Thailand, which earlier I was talking with Mr. Rao, where the cardboard cartons, like what is called aseptic pack, like Tetra Pak, there is a challenge because it is 7 layer, but Tetra Pak or the aseptic pack, 60 to 70% is cardboard or paper, rest is polymer and foil, aluminum foil. Now, if I can separate the 70% of the paper, keeping its structure same, it can go back to same application again rather than some other application. And that is the breakthrough has been done. We got the technology from Thailand, and I believe that for last couple of years, 2 plants are running in Thailand and 1 plant is running in Germany. And this technology we have brought, and demonstration plant is in Gwalior. We have put it, and there entire this uh, aseptic packs goes and get recycled, and the paper whole thing with the same structure, it goes back to paper industry so that it can come back again. Next, Mr. Rao. Here, like biopolymer versus biodegradable polymer, there is lot of talk in the globally not in only India, but globally talking about biopolymer and biodegradable polymer. What is the difference between that? Biopolymer is bio-based polymer, which I might make PLA or PLC, etc., coming from sugar cane or potato skin or say different vegetables, fruits, it is coming. And also from sugar cane, which is coming. That is, I feel very proud that my first job when I was in ICI, it was alcohol-based plant producing PE from alcohol to ethylene. And that alcohol is coming from sugar cane. And there is one plant running entirely on alcohol base in Brazil, Braskem, and they boost that our biopolymer. But understand, PLA-based biopolymer and that alcohol-based biopolymer is much different. Alcohol-based biopolymer is same like a fossil fuel or petrochemical polymer type, whereas PLA polymer it is degrade. But you for degradation of the product, it has to be collected after use and go for industrial composting and make compost. And now that biopolymer, bio-based PE, which is coming from PLA or PLC, the product property may not be similar to petrochemical products and difficult to process. This is there. So all bio-based polymers may not be degradable. One has to understand. Whereas biodegradation means we talk. The product over the days will gradually get disintegrate and degrade and disintegrate. But during disintegration process, it should not spoil the mother earth so that future generation will have problem in the earth for growing vegetables or any other thing or crops. That is called the biodegradation. We are working on biodegradation enzyme base, which also support by ISO enzyme base, because it is a multi-layer, say 3-layer polyester, poly 3-layer, which is generally chips and all these things packed. Those things today hardly it is collected. And basically, if a small, say, pouch for candy wrapper and it is disposed of, it is very difficult to collect the small pouch to let it biodegrade, maybe after 2 years. Let it that. And layer by layer, it let it degrade. Now, BIS has laid down a standard which is still temporary standard because we do not have enough data to substantiate a standard. So we adopted the ISO standard 17899, and that is for biodegradable and biopolymer case at varied condition. Because biodegradability absolutely difficult, because India, like a vast country, if something disposed in Himalayas, what is the time it will take to degrade? And if it is something disposed in a sea beach, what is the time? Because varied temperature, varied weathering condition, that has to be seen. There is another biodegradable compound which is called oxo-degradable. You know, all polymers degrade in presence of sunlight and oxygen. That is called UV degradation. Oxo-degradation has some negative point. Like if landfill this goes, if there is no sunlight, no oxygen, it will not degrade. It has to be there on the open street or curbside where enough sunlight and enough oxygen is there. Then will it degrade. And people does not know once it is degraded, what will happen to the earth. So several countries has banned oxo-degradable, but still it is used in Middle Eastern countries because where all the desert and other things are there. With desert and heat and generation and desert, nothing like fruits, vegetable, nothing happen. So they use like Saudi Arabia, UAE, they use oxidegradable. But in India, one of them country which has banned this. Next slide, Mr. Rao. Now, almost end of my talk, which is regulations. Next slide. Ah, European Union. European Union is the first who became the leader in regulations, bringing regulation for waste management. And the leader of them was first Germany, then France, and then UK. Of course, now UK has been separated. Yesterday only I was talking with one British fellow that what is happening to your country because you are separated out. They told still today we are following the European Union, what they're doing, but we are not in union. European Union took almost 6 years to bring this legislation. And finally, this legislation, final legislation has come in last December, and which has been implemented from this January 2025, where they say minimum recycled material content. It starts from 10% and gradually it will increase up to 65%. And it is for flexible different percentage, rigid different percentage. There is one good thing which is not in India, which is European Union established. They are designated, some auditors are there. A mechanical recycler, he has to announce that I am going as per the European Union regulations, and he has to appoint that independent what is called fellow or the organization who will do the auditing, and periodically they will do auditing. Based on their audit, they will get green logo. That means it is absolutely green. They are following regulation, everything, and the product is coming. Really, it can be used for food application, circular economy. And if it is find somewhere wrong, then his green logo will be taken out. This is the strictness in their European Union. Even one of my friend, who two friends are there, the partner, they have two plants in Netherlands near to Amsterdam. So I was earlier, time to time, I was talking with them. They applied for green logo. They told that absolutely difficult to get the green logo because from the bale waste plastic bales, from there they start auditing and go up to the last end and the paper management, all recording. So they were struggling for 1 year to get that green logo, and finally they got it. This is the strictness. Now they say European Union say a bottle is there. A bottle should have a label where boldly it should be declared that whether recycled material content or not, and how much quantity recycled material is added with the virgin material. That has to be there. So a customer can see, consumer can see that is happening, and the government can see this is happening. Germany long back they implemented when this rule didn't came that every packaging material, mainly rigid packaging bottles and containers, must contain particular percentage of recycled material. Without that, that product will not be allowed to be marketed. So the France told same time that recycled content will be there. I will give a special tax benefit, and if somebody does not use recycled, that tax benefit he will not get. And UK, what they have done, recycling tax they have put it, that whoever not Doing that, we will charge the recycling tax or waste management tax. What European Union says, that only not recycling, but you redesign your package gradually so that lesser and lesser of plastic you will go on using. There is some restriction in using of single-use plastics and reusing. There is target that reuse the product. This is the way they have made several targets. It is a document of almost 360 pages, whole document which has come up. Mr. Rao, next slide. Where Indian regulations, Ministry of Environment and Forest, Government of India, they have given notification in February 2022 based on a PM Waste Management Rule 2016. I was very much involved to making that regulations where they have talked about five categories. Five categories where is the rigid, flexible, multi-layer, then compostable and biodegradable. And every set they're talking that 10% to 80%, like a rigid bottle, minimum quantity 30% and going up to 80% year on year. And this regulation from 2024, it has been implemented with producer, and this regulation is called EPR, Extended Producer Responsibility for PIBO. PIBO means producer, importer, and brand owners. For producer and importer, it has been implemented from April 2024. And 2025 April, it is going for brand owners. And brand owners' responsibility is to collect their packaging material which has been disposed of as waste. And their circular economy means this has to be collected, send it for a designated recycling factory where he will recycle, he will send it to a packaging manufacturer, and finally it will go back to the brand owner. And everything in pollution control board portal, it will be added. And based on that, credit, like carbon credit, people will get the credit. And if somebody falters, then heavy fine. Same way, biodegradable, you cannot declare this thing biodegradable as not that you don't get a certification as per BIS standard tested. If someone declares fraudulently, then heavily penalized. I know one of the last year, one of the very famous cigarette company, that wrapper, BOPP film, thin BOP wrapper, he declared is biodegradable. And it was been tested and found it is not degradable. So heavily he has been fined. Now, for a cigarette company of international standard, fine that few crores is not matter, but mainly matters his image. That is, newspaper, every newspaper came up the news. It is matters his image. With that, thank you very much, because almost time I am making up. Mr. Rao, thank you for giving me this opportunity. Any questions is there, then I can reply.
Oh, thank you, Mihir sir. It's really very informative presentation. I enjoyed this presentation. It's a lot to learn, and I think, guys, if you have any questions, you can post your question in the question box. We can discuss now. Actually, some people posted a couple of questions. I'm going to ask you these questions.
Yeah.
Can you hear me well, sir? Yeah.
Yeah, I can hear you.
Yeah. Okay. This is a question, but I'm kind of summarizing it. In a lot of many places, plastic cups, plastic straws, plastic bags are replaced by
Yeah.
paper cups, paper straws, and the paper bags. Do you think is this a sustainable practice?
To be fair, frank enough, first thing I'm talking about plastic cups, paper cups. There is not purely paper. It is coated with plastic or PLA. A paper cannot hold the coffee or tea. That is, everybody knows. It is coated either with PLA or paper. Like first such jugglery has done in tobacco packing. When
Hmm.
it was been tobacco multi-layer film was banned for tobacco pouches, and they told paper, okay, outside paper printed on it, but inside PE coated. Everybody knows, but nobody shout. Without that, paper cannot be sealed. And a tobacco, if moisture goes, then entire tobacco gone.
Yeah.
And paper bag, like how long you will go on cutting the trees? Because if paper recycle, there is a study has been done. I can send anyone the study. The carbon footprint of recycling of papers is horrible. Carbon footprint is much higher than plastic recycling and environmental effect. Okay.
Yeah. Yeah, I think it's more education needed for the regulatory authorities to understand clearly. I think the negative image that plastic gets into, yeah, yeah,
Yeah.
yeah. Okay, there's another question here. Are there opportunities nowadays for the entrepreneurs who wants to enter into the plastic recycling business?
So
And
first question come.
what kind of incentives Indian government is offering for new entrepreneurs who wants to enter into the plastics recycling? Yeah.
First thing, we are breaking our head to let government understand that some incentive should be given, but there is still today there is no incentive. Now, what type of recycling and what recycling you are going to do? If downcycling you are doing, there are hundreds and hundreds of downcyclers are there all over India. In Delhi itself, few industrial area full of those who are doing regular basis for last 20 years downcycling. Indore is one of the place where a lot of done and all over India. But if you are looking at upcycling, yes, there is incentive, but proper technical way you have to do, and you have to get proper technology. Without that, no. Like I have been told that recycled PET, which is going for food packaging, that is 10 to 15% costlier than the virgin material. And when regulation has come, you have to buy. A brand owner has to pay the money. And of course, brand owner will not absorb, it will be absorbed by the consumer. But 10 to 15% higher cost. Without that, can you think that some 14 machines are in pipeline and each project cost around 4 to 500 CR, these projects. And their washing capacity is to 4 to 5,400, 4,000 to 5,000 kg per hour. There is the volume. Okay.
Yeah. Sir, can you sit back?
But
Sir, can you please sit back onto the camera because you're coming to the front. Yeah, sit back, please. Yeah, okay, that's good position.
okay.
Thank you. There is a question here about the bottle-to-bottle technology. You mentioned about that is, I think there are two machines are into India or some.
All imported.
All important. Can you talk about more about what is that technology? From which country is that?
Okay. See that washing line, mainly Germany, but again from China, washing lines are coming, which is much cheaper than German. Difference between Chinese washing line and European washing line, not much technology difference, only the steel raw material which is used. Because when I was talking to one of my friend who manufactures washing line in China, he told say that if I use the same steel, the price of will be same to Europe, then why you should buy from me? My machine, after 5 years, you have to go for repairing, but a European machine, after 20 years. That is the difference. Washing line, you can get from Europe. Europe, there are some companies, very well-known companies, that those machines are already operating in India, like Sorema, Herbold, Lindner have opened an office in India. Herbold represented by someone, Sorema is represented by someone. Whereas the main, not the washing line, of course, there, but cracks of the thing is extrusion, where what type of extruder you should use. There are mother baby extruder, which mainly Chinese they give, but European they give two-stage extruder, where the vacuum is removed, then contaminations removed. Like leader so long was Erima, one of them for extrusion. Now, of course, Sterlinger has come. Recently, I saw a machine in India, Coperion. Coperion is a very famous compounding machine, but they are now offering, and they say that you do not require degassing like Sterlinger or like Erima in my machine automatically because it is a twin screw extruder. So it is going on like this, same way. And these machinery manufacturer, they have got our NGR, like German, they have got FDA approval directly. Now, if I was working with one of my client, we met with Erima. Erima told, before I am selling the machine to you, you have to send me at least 1 metric tons of the waste which you are going to do recycling. I will run in the machine and see the product. If I'm not satisfied, I will not sell you the machine. So in Erima machine you buy, automatically you are becoming FDA. But I don't agree with that, to be frank enough, which we have put a lot of debate when we were making the standard of PET recycling. A lot of debates were there based on that. Same way Sterlinger, Coperion, NGR is LSP process they are developed, they are doing. I believe one of the Chinese company, he has got also extrusion FDA approval. So he is supplying extra. I have visited him here in Nanjing. His factory is in Nanjing. I have visited his factory. Good, very good extruder, and they got recently FDA. This is the technology. Anything, sir?
There is one more question here. How to reuse the PET lumps?
See, PET lumps is again going for recycling, mechanical. It can be used, recycle it. But what product you are making depends on that final product, where it will go. There is an opportunity which I have not covered because absolutely difficult, which I told you in 1 hour. That is engineering polymer recycling. Lot of engineering polymers now coming because with EPR, like packaging, this EPR packaging, EPR has come for electronics much earlier than packaging, and then EPR has recently has come for automobile, because some of you must be knowing, or everybody knows with India, that a diesel car after 10 years you have to scrap it, and a petrol driven car after 15 years you have to scrap it. So those car has to go for recycling, and I have seen at least 5-6 recycling plants in China. So beautifully they are separating each thing. And in automobile or electronics, you get a lot of engineering polymer like ABS, polycarbonate. And these materials are acute shortage in India. ABS is acute shortage in India. Around 80 to 85,000 metric tons per year imported from Korea, and single company called Kumo, they supply it. So there is a chance going for ABS recycling and make near prime, upcycling, near prime. You must analyze what grade it is ABS, which he has got, and to match the same grade, I have to do. Same way polycarbonate. Polycarbonate not made in India, its entire quantity is imported. Anything wrong, sir?
Yeah, there is
Any
one
question?
last question here, one more here. You talked about PIBO, producers,
Hmm.
importers, brand owners, recently started, but what you mentioned, and
It will
how
be starting
effective
from March, April. It is
Oh,
starting from April 2025.
or
Yeah.
25. I see. Okay, that's interesting. Yeah. Okay, so that's the end of the questions we have. I think we end the session now. I really thank you for doing the session today and enlightening us with the about plastic recycling, about technologies, regulations, possibilities with the from linear to circular economy. Before I let you go, would you like to give a final message to the audience, please?
See, everybody is manufactured plastic film or molded products, everything. But recycling is a business you should look not by downcycling but upcycling. And we are the leader. Asia is the leader. Asia is the leader, not the Europe. European machines we are buying, but they are not leader in recycling. Leader is Asia. So look at that. And whoever has looked at that, they have spent 4 to 500 CR for the project of PET recycling. Because with EPR coming, these brand owners has to go, and the large brand owner like Coke, Pepsi already announced for going for themselves PET recycling with one of their bottler called Barun Wave and Indorama, who will be supplying PET chips. Indorama himself has a recycling plants in Thailand. They have recycling plant in Nigeria. Now they are putting in India. I do not know how many of you know. For when I was working in Reliance about 12 years back, from those days, Reliance is one of the largest recycler of PET. Earlier, those PET recycled and going for fiber application, and Reliance sell a pillow called Recron pillow, and the inside Recron pillow there is no cotton but all these fibers, and that is the reason they say it can be washed. It is washable, this pillow. So already these are there, but now with EPR coming, and I hope this Prime Minister, Mr. Modi, if he is staying back, it is his dream project, because in Davos, last Davos meeting, he has given assurance to world by 2030 circular economy in plastic I will bring in India, and it is his brainchild. So it has to come, but proper. I have worked with one of the recyclers who were already making, they're the one of the leader in HDP bottle in India, supplying to all the multinationals. Backward integration, they have put a recycling plant of HDP, small plant, because I told them, first you understand what is recycling, then you expand. And they're doing well, I believe. So HDP recycling or polypropylene recycling or PET recycling, not only PET, but HDP bottles recycling. Because easy to collect the bottles, not the films. Anything, Mr. Rao? Further questions?
That's all, sir. Thank you very much. I appreciate your time and contribution today for this today's plastics tech talk on the plastic recycling, a journey from linear to circular economy. It's a fantastic session. I really enjoyed it. I'm hoping to inviting you, talk about more other issues about the plastic industry. Yeah. Thanks once
Certainly.
again. Yeah. Thank you very
Thank you
much.
very much for giving me this opportunity, Rao sir. Someday we will meet face to
Definitely.
face.
Definitely. Yes.
Okay.
Thank you,
Bye.
sir. Thank you again. Thank you.
Thank you.
Okay, guys,
Thank
that's the end of the session today of the Technobiz Plastic Tech Talk, plastic recycling, a journey from linear to circular economy. I'm really hoping that you find this session useful. And also, I encourage you to connect with Mr. Mihir Banerji to explore the opportunities for the collaboration on your plastic recycling project. And a special thanks to the Polyconnect, because Polyconnect is the one, Mr. Khan is the one connected with Mr. Mihir Banerji. So I'm very much thankful to Polyconnect team and Mr. Mihir Banerji once again for being part of this session today. Thank you all. I hope to see you in
Thank
the
you.
next episode of the Plastic Tech Talk. Bye bye for now.
Bye.